Good day everyone, I'm Jeter Josh Aragon and I'll be discussing the usage of rules of inference and fallacies. Here are the rules of inference we may reference once we identify the rule used in the argument, which will be presented later. Preceding propositions are called premises or hypotheses, and the last proposition is the conclusion. As you may notice, a particular symbol is used in the conclusion. The symbol is read as therefore. I encourage you to pause this video and take a moment to understand the rules of inference presented. Identify the rule of inference used in the argument. If Judy is a judge, then people will follow and respect her. But people will not follow and respect her. Therefore, Judy is not a judge. As we have learned from the last video about translating a statement into a compound proposition, we should first assign the propositional variables to each statement. Our first propositional statement is the sentence, Judy is a judge. Hence, let P represent the statement, Judy is a judge. Our second propositional statement is the sentence, people will follow and respect her. Therefore, let Q represent the statement, people will follow and respect her. Look for the propositional connectives we can use. In the first sentence, we may quickly notice the use of if and then, which indicates implication. Hence, our first hypothesis is read as P implies Q. In the second sentence, we can observe that the proposition Q is used along with the negation. Thus, not P is our second hypothesis. For our last sentence, aside from the negation of proposition P being used, the word therefore is used. This indicates our conclusion. Hence, we have our conclusion, therefore, not P. Now that we have the hypothesis and the conclusion, we can determine the rule of inference used in this argument. Looking back to the rules of inference presented earlier, we conclude that this argument uses modus ponens or the mode of denying. Remember that while we have these rules of inference that we consider valid arguments, there are also invalid arguments based on fallacies. There are three kinds of fallacies: the fallacy of affirming the consequent, the fallacy of denying the hypothesis, and circular reasoning. Since circular reasoning is not mainly based on a specific compound proposition, we'll focus on the first two fallacies mentioned. Please take a moment to understand the two fallacies presented. If you observe closely, the hypotheses and conclusions of both fallacies are similar to the two rules of inference presented earlier. The mode of affirming for the fallacy of affirming the consequent, and the mode of denying for the fallacy of denying the hypothesis. Take note of the differences between this set of fallacies and rules of inference. Identify the fallacy that occurs in the statement. If I have caffeine, I will be awake all night. I am awake all night. Therefore, I have caffeine. Again, let's assign the propositional variables to each statement. Our first propositional statement is the sentence, I have caffeine. Hence, let P represent the statement, I have caffeine. Our second propositional statement is the sentence, I will be awake all night. Thus, let Q represent the statement, I will be awake all night. An implication is used in the first sentence. Implications don't have to use the words if and then in all cases. Instead, we can look at whether an antecedent and a consequent exist in a statement. Thus, we have our first hypothesis, P implies Q. In the second sentence, proposition Q is used in present tense form. Hence, we have our second hypothesis, Q. In the last sentence, the word therefore is used along with the proposition P. Hence, we have the conclusion, therefore P. As we look back to the forms of fallacies presented earlier, we can conclude that this statement is a fallacy of affirming the consequent. If you think of it, when I say I was awake all night, it does not have to mean that I had caffeine. It could be that I had to study for a test, or I can stop thinking of my plans for the upcoming break. This statement will be more logical, or to put it simply, it will make more sense if I hypothesize that I have caffeine and conclude that I will be awake all night. This is why this statement is a form of fallacy.